So this is a lecture 43 according to your lesson plan, and in this lecture we are going to discuss about the system response using the Z transform. Okay, what is the system response of your given system, how to calculate it. Okay, so we will talk about this. Now if I talk about the any LTI system, okay, suppose you have a system, means you are giving the xn, you are getting the yn over here, and hn is the your response of the system. Okay, now all of you know, if you want to calculate the value of yn, okay, in first unit we have seen yn equal to xn convolution with the hn. Now you can take the z transform this equation. So all of you know, when if you are taking the z transform, that will be multiply in that case. So yn का क्या हो जाएगा yz, xn का क्या हो जाएगा xn, and that will be multiplication of the hz. ये हमें पता है, ये हम देख चुके हैं, directly multiplication. So where yz is the z transform of yn, xz is z transform of xn, and hz is z transform of hn. So from here you can write it down, this hz equal to yz upon xz. So this hz is called the system function, or the transfer function of the LTI discrete system. And is defined as कैसे डिफाइन कर सकते हैं? ऑब्वियसली फर्स्ट थिंग हमें दिख रही है द रेशियो ऑफ द yz अपॉन xz, yz एंड xz. सो द रेशियो of the z transform of the output sequence, that is your yn, to the z transform of the input sequence, that is your xn, when the initial conditions are neglected. Now इसी में एक जो important हमारी है second definition, if the input, and that is important, if the input xn is impulse sequence if the input is impulse sequence, मतलब xz की वैल्यू अब क्या होगी 1. इन दैट केस जो hz है वो किसके बराबर हो जाएगा yz के. So the transfer function is also defined as the Z transform of the impulse response of the system. So you have to remember, whenever we talk about the impulse response, in that case we are taking this xn equal to 1, xn equal to delta function, impulse function, and that impulse function or delta function both are same, so that will be hz equal to 1. Now all of you know that I'm just writing because we already seen this type of equation. Hz equal to क्या होता है yz upon xz, and this yz upon xz can be represented in the term of polynomial. Okay, if you remember, we have seen this equation when we talk about the starting of this unit Z transform. A naught plus A1 Z inverse plus A2 Z to the power minus 2 and so on An Z to the power minus n. Here Z to the power n. So we can represent our this transfer function in the polynomial form, or you can say in differential equation form also. Okay, so इसी को if we want to in the summation form, so k equal to 0 to capital M bk z to the power minus k upon summation k equal to 0 to n ak z to the power minus k. So you can represent your transfer function or impulse function in this form also. So you can say the transfer function और differential equation के बीच में क्या relationship है. Okay, that is defining by this term. Okay, so that is your transfer function and these are your differential equations. So कैसे हम एक ट्रांसफर फंक्शन को या इम्पल्स रिस्पॉन्स को डिफरेंशियल इक्वेशंस में हम कैसे रिप्रेजेंट कर सकते हैं, ये यहाँ पे हमें पता चल जाता है. नाउ इसी में अगर वो आपसे पूछ लेते तो व्हाट इज द फ्रीक्वेंसी रिस्पॉन्स. सो रिमेंबर व्हेनेवर वी आर टॉकिंग अबाउट फ्रीक्वेंसी रिस्पॉन्स, so for getting this frequency response, you have to put z equal to e to the power j omega in hz. ये ध्यान रखना कि frequency response के लिए you have to put z equal to e to the power j omega. Okay, although we already know कि z की value क्या होती है, so you have to put this if you want to calculate the frequency response. Okay.